Here is a test problem for you. Have a good look at it and answer the question. The question is, identify the parent function f of x. So this is my parent function f of x, right? Write the equation of the transform function g of x. The one in bold is g of x. How are the points in two graphs related? So that is the part of the question. Now, when you look at it, this is f of x, remember. The thin lines are the main functions and the thick lines are transform functions in all my videos. Now, the main function, as you can see, f of x is what? Is called reciprocal function. And it can be represented algebraically as f of x is equals to 1 over x. So you can see that x is not equal to 0. So it is an important restriction which you should always put. Reciprocal functions are unique in the way that they have both horizontal and vertical asymptotes, right? And 0 is not in their domain. So domain is all real numbers except 0. Range is all real numbers except 0. So I'll add one part for you to answer, and that is write domain and range for the function, right? So write domain and range for g of x, the transform function. So that is an addition to the given question. Now we need to identify the parent function, which we have done. So we'll say parent function f of x is 1 over x. Now write the equation for transform function g of x. How are the points in the two graphs related? And write domain and range for g of x. Now let's look into how to write the equation for the transform function. So if you notice, what do you notice first thing? So this is f of x, and g of x is kind of a reflection on the y-axis, right? So that indicates x minus, right? Minus with this will give you a reflection on the y-axis. So first transformation which you notice is reflection on y-axis, right? What else do you notice? It is not really congruent. You notice that it is kind of stretched or compressed horizontally, right? It is not kind of same. So it has some factor. Now you can compare it by looking at it. So the critical points to test always is 1, 1. These are the critical points to check with. So you notice that if it was a simple reflection, then this point should have come here. But it is not here. It is in a different position. It is actually shifted more, twice the distance away. Do you see that? So it should have been after reflection here, but it is not here, but it is at this place, which is -2, and this point is 1. So I was expecting this point 1 after reflection to be at -1. But since it is not at -1, it is moved further away. So moving further away means horizontally stretched. So the second is horizontally stretch by a factor of how much? 2. Since it is twice the distance away. Do you see that? One shot, you get your answer. So this is probably the best way of reading your graph. So have a very close look and try to understand what is happening. 1, 1 is a most critical point on your reciprocal function. It helps you to get the right answer. Correct? So we got these two transformations and nothing else is changing here. The asymptotes are same, right? The asymptotes are, horizontal asymptote is y equals to 0, vertical is at x equals to 0. They are not changing, but this is a major change. Your point is moving away. You will notice here also, this is at -1, but it was pushed to +2, right? So minus is for reflection and then times 2. Now with that I can write down the equation of my transfer function. So I get g of x should be equal to what? Can you help me in this? So it is reflection, right? So it is minus, so let me write 1 here. We are doing nothing with the vertical thing, right? So we are doing minus here, and second is horizontally stretched by a factor of 2. When it is horizontally stretched, we'll write half of it, right? So half of it. Do you see that? X. So that is how your function is. So when you really simplify it, you can always write this as minus of 2 over x. Do you see that? Now, so that way you get your equation. Well, at times you could also see this graph in a different perspective. That is, you could reflect this on x-axis. In that case, this minus will be treated as outside this function. Do you see that? So it's reflection, and 2 times will be stretched by a factor of 2, right? You can see instead of 1, this is also times 2. So either way, we could have looked into this and got the same result. If you are looking the horizontal way, then that is the right answer. But it should be written like this. And when we go back, so what you learn from here is that if it is horizontally stretched, then it gives you an effect that it is vertically stretched too, correct? So that is how you can see it. Now, as far as the domain and range is concerned, it remains the same as it was with your parent function, since there is no translation involved in it. So that is kind of important to note. I hope that helps you to understand how to write equation from the given graph, in this case when we have a reciprocal function. Thank you.